Hello, my Fear Foundation students. It's Professor Bedrero, and I'm creating some videos to help you learn a little bit more about statistics, risk homeostasis theory, and data analysis. I'm posting this so you can view them online and work at your own pace, provided that you meet the deadlines, of course. I realize that reading what is on the screen is not optimal for an in-class lesson, but I'm trying to make these videos as accessible to those with disabilities as possible, so please stay with me. I like working at Snow because most students are sincere in their desire to learn. I expect that most will watch the videos and learn, even if there are questions. However, based on over 20 years of teaching experience, I know that a handful of students will try and game the system by not watching the videos and just asking questions that could easily have been answered by watching the videos. I want to answer honest questions, so I've decided to place a couple of clues in each video. If you ask a question, I will expect you to first tell me the clue or clues in that video. For example, I might tell you that the clue is my favorite color, blue of course. And with this method, I expect to have more time to make quality videos and less time taken up by students who are not doing their part to learn. For this first video, I'll even let you know what the clue is going to be for you to look for. The clue is, what is Professor Bedrero's favorite color or flavor of jelly bean? Now let's get started. If you haven't already, please pause the video, go to our Canvas course, click on the class schedule, and download the activity for one proportion confidence intervals listed for March 30th. Then resume the video. Note, I've made the font larger on this version, so the pagination may be slightly different than the one you download online. Now that you've downloaded the activity, let's go through it together. We're going to be talking about finding a proportion for a proportion confidence interval. So our objectives are to calculate and interpret the margin of error and one sample proportion confidence intervals. To start off, let's remember some definitions that we learned earlier in the semester. A population is the entire collection of individuals or objects under study. Okay. And that might be all Snow College students or all Utahns or all Americans. But you'll notice that these populations tend to be rather large. So we have a very hard time getting a hold of everybody and measuring the desired characteristic on each one of them. That's where statistics come in. And so to do that, we need to take a sample. A sample is a subset or subgroup, sometimes people like to say, of the entire population. So we take a very big problem and, like asking all Snow College students or all Utahns, and instead of trying to spend all the time and energy to do that, we take a properly chosen sample and our answers will be close to what they would be normally, or if we were able to get everybody. And that's exactly the purpose behind statistics, is to make conclusions about the entire population without having to ask everyone. We do this through taking samples. Since a sample only involves a part of the population, our results will not be exactly the same as if we were to ask everyone. However, they will be pretty close as long as our sample is taken randomly. Okay. So the formal name for how close we are, if you've had a statistics class, you've learned about the margin of error. Okay, how close our sample number is likely to be to the true population number. Okay. For your final project in this class, a lot of you will be working with categorical, aka qualitative data. You will recall from earlier in the semester that this is a non-numerical characteristic of each member of the group, such as eye color, handedness, or fear levels with very afraid, afraid, slightly afraid, and not afraid. When dealing with categorical data, we count the number of elements with the desired characteristic and then divide by the total number in the group. This number is called the proportion, or percent, part of the whole, of the group that has that characteristic. If the proportion is computed for an entire population, we call it the population proportion, and we use the symbol little p. If the proportion is calculated for a sample, on the other hand, it's called, oddly enough, the sample proportion, and we represent that by the symbol p hat. Let's do a simple example here. In a particular class, there are 17 females 12 males, and 1 LGBTQ student. The proportion of students in the class who are female is 17 out of the total of 17 plus 12 plus 1, which is 30. So 17 out of 30, which if we do that on a calculator is 0.567. And remember, we could convert that to a percent if we wanted to, 56.7%. So I want you now to find the proportion of students in this class, rounded to 3 decimal places, who identify as male and as LGBTQ. I'll give you a few seconds to do that. I went ahead and did that and found out that the proportion of students in this class who identify as male is 0.400 or 40%, and LGBTQ was 0.033 or 3.3%. I guess I only need that one. Okay, so let's move on to the next part. In my statistics classes, I have my students analyze the color distribution of M&Ms. It's a sweet example because the kids get to eat the candy when they're done. In one class in the morning, there were a total of 214 M&Ms in the sample, of which 53 were blue. Find the sample proportion p hat of blue M&Ms rounded to 3 decimal places. Give you a second to work on that. I just typed that into my calculator, and if I get this so that the screen you can see it, we can see that it's 0.248 rounded to 3 decimal places because this 6 would round that 7 up. So 0.248, or if you wanted to think of this as a percent, that's 24.8%. Okay. In the afternoon class, we had fewer students, so we had a smaller sample. Find the sample proportion of blue M&Ms in the afternoon class, where there were 38 blue out of 167 total M&Ms. I'll give you a second to work on that. Doing that on my calculator, I got 0.228 rounded to 3 decimal places. Okay, so that would be, if we wanted to convert it to a percent, 22.8%. But mostly we work in decimals. Occasionally people think of them in percents though. Okay, so we did some research. We actually found somebody who contacted the M&M's company, and the plant in Cleveland, they say that they package their M&Ms in packages that come from a giant mixture where 24% of them are blue. So how did our 2 sample proportions compare to the population proportion P? I'll give you a minute to work on that, and then we'll come back and talk about that together. Now might be a good time to tell you that my favorite color of jelly bean is black. Yum. So in sample 1, the AM class, our sample proportion was 0.248, which is very close to the population proportion of 0.240. Similarly, in the afternoon class, the sample proportion of 0.228 is quite close to the population proportion, but in this case, he was actually a little bit lower than the 0.240. We'll stop there and pick up in the next video.